Hello everyone, welcome back to our channel. This is lecture series 18 Embedded C Basics dealing with different kinds of Viva question based on 8051 microcontroller. Come, let's go into the video. What is the size of program and data memory? So we have learned that program and data memory is nothing but the RAM and ROM in the other series of video. So now we are going to see what is the size of the program and the data memory. So your internal RAM, that is your data memory, where the data is being stored in a kind of register. So that internal RAM will have 128 byte size. And program memory, which is otherwise called as code memory, internal memory, it is of 4 KB. So data memory is RAM and program memory is ROM. Then how many address lines are required to address 4K of memory? So now 4K of memory is available in the microcontroller. Now to access that, how many address lines has to be there? Address lines is nothing but when you are using the ALE program, that is assembly language program, you will be using different kind of instruction. So to pass those instruction addresses, instructions to fetch the data, you will have address lines. So totally you will have 12 address lines which is required for your 4K memory to be accessed. So what are all the 12 addresses is nothing but these are the pins: data input, data output, address inputs, ground. So address input you have A0 to A8. So 9 pins you have as address inputs. Other than that, you have data input, data output. All these are the address lines. And next question, what is the function of the accumulator? So we all know what is accumulator, right? In the general structure of 8051, we have studied. It is nothing but it is a register which is going to store your result. Whatever result is extracted finally, that result will be stored in the accumulator. So for 8051, it can hold 8-bit value. That is 8-bit is equal to 1 byte of value. Okay. So for it, the value that the accumulator holds will be different for different sets of microcontrollers. What is SFR? Explain briefly. So SFR is nothing but special function register. So in 8051, in architecture, we have seen we have accumulator, B register, C register, D, E, all these register. These are the register which is permanently there in 8051 to store the values. But the special function register is nothing but it will be holding the addresses above 80 to FF. So it is not the regular register where the data is being stored. There are some special register which is used for different functions. Say this kind of memory will not be used for data or program storage. Then where it is used? It is used for memory mapped ports and register. That is, you can see here, power control register, program status word. So these are kind of special function register. Program status word is nothing but it is going to tell you if there is any rise in flag. Flag is nothing but when there is a carry flag, when there is a 0 flag. Then PSW, that is program status word, will indicate that you have timer 0 high order. So it will be telling that in timer 0, which is the higher order address, which is the lower order address. So for that kind of functions, SFRs is being used. And next, what is the program counter? What it is, for what it is used? So here program counter is nothing but it will be representing the instruction which has to be executed next. That is, see here, this is the instruction that is being executed. Instruction 3. Now your program counter will be pointing to the next instruction that is in line for execution. So then what does stack pointer means? Stack pointer is nothing but it is a kind of register which will store all the memory addresses. So stack means once the stack is put in a word, you should remember that it has option push and pop. First in, first serve basis, right? That we know, right? So likewise, stack has an option of pushing and popping of datas. first in, first out. So first data which go and sits in a stack will be taken out first. It is push and pop function. You are pushing the data inside and taking out the data through pop option. So stack pointer is a register that is used for storing the memory addresses in a form of stack. Next, what is the size of, that is stack pointer and program counter? So stack pointer is nothing but it is just going to store the data, right? So for 8051, it is 8-bit wide, that is 00 to FF. And program counter is 16-bit because it is going to show the address or instruction which is going to execute next. So that can be of any bit. It is not that it should be 8-bit. 16-bit it will represent, but when executing it can be 8-bit. So program counter is 16-bit and SP is 8-bit. So now what is PSW? So we have seen what is PSW, program status word. So, and briefly describe the function of it. Now you will see. See this program status word, it is a 8-bit register. It is a flag register which is going to show you which flag is being arised during your performance of your program. So you have carry flag, auxiliary flag, register, then there is a general purpose flag, overflow flag. Overflow is if there is so many number of data for an 8-bit, only 8-bit data can be stored. If there is more than 8-bit, then it is said to be overflow flag is set. Parity flag 0 and 1. User definable bit. So these are some of the flags that will arise during your execution. To show that flag arising, PSW is used. What is the difference between PC and DPTR, that is program counter and DPTR? So program counter is nothing but what I have told you, it is a 16-bit which is going to show the address that has to be executed next. But DPTR is nothing but it is divided as data pointer high and data pointer low. That is data pointer will be high is nothing but the bit at the higher side, higher value, higher address. Low means data pointer at the lower side of the address, LSB, MSB. So here you can see this is DPTR 16-bit where 88 bits is divided as high and low. So high is nothing but bit 0 to bit 7, that is your address is ranging range as 83H. It is 82H for DPL. And finally, what is the difference between the program counter and the stack pointer? So program counter is nothing but it is the one which is going to show the addresses executed next. And this is the one which is going to address all the data, store all the data, and it is going to address what the program is requesting from the stack, whether to push or pop. And the CPU register for the program counter will indicate whether it is in a sequence, whether the program is executing in the sequence. Stack pointer, it will keep on track based on the stack, whether it is push or whether it is pop. Based on that, first in, first out, last in, first out, all those will be there. So here stack pointer you can call as stack register, and program counter you can call it as instruction address register or instruction counter. Okay, so this will be completely tracking the operation of push and pop in the stack, and this will be completely tracking the execution addresses, whether it is done in sequence, right? Hope you have understood this 10 series of questions. Please stay tuned for more information. You will be seeing other sets of series of Viva questions. Thank you.